Welcome to the first video of the series Concurrency Programming in Python. This is going to be the introductory video. So what is concurrency? Concurrency enables the execution of multiple tasks at the same time, enhancing overall efficiency. Nowadays, our CPUs have more than one core, but our program only going to take one core to execute up to the end. If we make it parallelizable and use all the cores, the speed of the program increases. Before diving in, let's look at the definitions of some keywords. Process. A process is like a program in action. Imagine it is a person doing a task. Each person has own resources like memory and files operates independently. So multiprocessing, you can think of it as imagine a restaurant where each chef in the restaurant have his own kitchen. Thread. A thread is like a small unit of process, similar to single worker within a large project. Threads within the same process share resources like memory and work together to accomplish. So multi-threading, you can think of it like a restaurant where all of the chefs use one kitchen and share all the resources. The main difference between the sequential and the multiprocessing. Sequential runs the code one after the other only after the previous one finished executing starts. But the multiprocessing runs all the code at the same time and produces result. Let's take a look at the example Python code to implement the concurrency. So here we have a simple sequential code with some work function inside it. Inside the function, we have a for loop that does nothing. It is here to depict some sort of action, some sort of work, and we call the function in a for loop 10 times. Well, for loop by default is a sequential code. It runs one after the other. So if we run this code, we get this output. It says I am 0, 0 finished executing. Only after the previous one finished executing, the second one starts. And 1, 1 finished, and 2, 2 finished. So it is sequential. Now let us convert this sequential code to concurrent code by using a Python module called concurrent.futures. So let's import the module, import concurrent.futures. We use the module as follows. With concurrent.futures, this concurrent.futures module provides us with two classes to implement concurrency. One is thread pool executor, and the other is process pool executor. Let us use process pool executor for now as E for executor. We can submit some functions to the executor and it will create processes behind the scenes and run them in parallel. So we submit our function some work with input 0 and it will return a future to us. The future equals to e.submit some work. We'll use this feature to know when our process is going to be finished by using concurrent.futures.asCompleted. So for future in concurrent.futures.asCompleted. This will take an array of futures. Right now we only have one, so we pass the future. When we print future.result finished executing. Now the future.result is nothing but whatever we return in this function some work. So right now we're just returning the input we just gave, so it should print 0.finished executing. Now before we run this program, we have to do one last thing, that is to enclose all this code inside an if block. If name is equals to main. This is to ensure that not to create infinite loop or to create an error, because under the hood, when we create a new process, we are using operating system's fork method. Now the fork method will actually copy the entire code when a new process is created, that is including the creating of new process again. So we only create new process if it's absolute main process. Like if it's a parent process, create the new process, otherwise don't do it. That's why we kept our code inside this name block. Now we can run this. we get result 0 and 0 finished executing as we expected. This is to submit one function. Now we can submit an array of functions or same function multiple times. Let's do this. Features equals to array e dot submit some work with I for I in range of 10. Now we submitted 10 times our function and got all the features in an array features. Now we can use for feature in concurrent dot features dot as completed. Now our array is already ready, so we don't have to enclose it with square brackets. We just pass the features and print feature dot result finished executing. If you run this program, as you can see, it print AMP0 and without finishing. So the 0 essentially finished here, but without finishing 0, it also started 1, it also started 2, and the order particularly does not match every time. It can finish some functions later. The starting of the function does not matter because they run in parallel and they can finish in at any moment. If you remember the previous code, they just execute in order. So it's just I'm 0, I'm finished, I'm 1, I'm finished. Now let us look at a real example where we might use concurrency. We have 4 functions here, and the first function is isPrime. It is just a standard prime checking function. It will take a number and return true if it's a prime and false otherwise. And we have primes in range function. It will take 2 inputs, the start range and the end range. It will loop from start to end and count the number of primes and return the count. And we have 2 functions, total primes concurrent and total primes sequential. Let's look at sequential first. It will just loop from 0 to the number we have given, the range we have given, and it count the number of primes and it print the number of primes and time it took to find them. It is just a sequential code because we are just using the for loop. Let's look at the concurrent now. For concurrency, first we have to split the input into 10 parts. For example, if you give 1000, you have to split it like 0 to 100, 100 to 200, and so on and so forth. So we can pass each range to a process and compute them in parallel. So find the ranges, and each element in these ranges is a tuple from I to I plus up to n by 10. We are using for loop to do this from 0 to up to n, and we increment each time the iterator by 10th of the given input. And we are using concurrent.futures.processFull executor as executor. The max workers for here tells us that it's gonna use 4 cores at max and it won't use more than that. So futures is equals to, we submit our primes in range function with the inputs range of 0 and range of 1, where range come from looping the ranges. So for range in ranges, we looping each range and submit to our executor its own function with its own range. So it will run them in parallel, and once they finished, we just increase the count of their range. So for example, if the count from 0 to 100 will be added to total primes, and the count from 100 to 200 will be added to total primes, and so on and so forth, it will find all the primes in the range, and it will print them, and also the time it takes to find them. We are running the 2 functions, concurrent and sequential. Let's run this Python code, py. So the concurrent took 1.4 seconds and sequential took 3.5 seconds to find them. It is better, so concurrency is better, but there's a catch. If we just reduce the count, so if we are just finding the total number of primes in the range of 1000. Let's run this again. So the concurrency actually took more time than the sequential because there is overhead for creating and managing the processes.